Okay, so this is notes for homework 71, which is 3.3 in your textbook. And example number 1, the directions say to evaluate the function when x equals -3 and 4 and 0 and 6. So basically they're giving you the inputs of -3, 4, 0, and 6, and they want you to find the outputs. In problem number A, the function is called the v function. So the function here is the v function, and remember, we're going to put in place of the x. These are the inputs that they want us to put in. So you're just going to go and do the work for one at a time. Show our work. And so we're going to say, well, what happens when we plug in? Let's start with -3. So we could say v of -3 is going to be 2 minus 3 times -3 minus 4. So notice I just recopied the rule, but in place of x, I put -3 for this go around. And then we just do order of operations. So it's 2, right, because you have to multiply first. So 3 times -3 is -9, right? And then we can subtract a negative, so that actually gives us 11 minus 4 is 7. So we can say that when you plug in -3 into v, you get 7 out. And then we just do it over and over again. Now we're going to do it for 4. So we're going to say v of 4. And we're just going to copy this down, and wherever we see an x, we're going to put +4 in it this time. So it's hard on the eyes, so you have to go back and look for copying errors, because I know I make copying errors all the time. So you want to go back and look and make sure that you wrote everything else down correctly, because it's so hard on the eyes because your eyes are moving around so much. And then order of operations says you have to do the multiplication first. So 3 times 4 is 12. And then 2 minus 12 is -10, and -10 minus 4 is -14. So you get -14 out of the machine when you plug in 4 into the machine. So we like to use this style of notation because this style of notation tells the reader that when you plugged 4 into the machine or into the v machine, you got -14 as the output. And then we're going to do it again, and we're going to do it for 0, then we're going to do it for 6. So what you could do is you could pause the video and try 0 and 6 and see how you do. We'll see you in a moment. So did you get v sub 0? V of 0 is how you read that. Equals -2. In other words, when you plugged -2 into the function, did you get -2 out? When you plugged -3 into the function, did you get 7 out? When you plugged 4 into the function, did you get -14 out? And what happened when you plugged 6 in? So let's double check it. So pause the video, you try it, let's see what happens. So is that what you got? Did you check your lines? And so that's basically what you're doing on your homework tonight. That's one example. Evaluate the function when x equals -3, 4, 0, and 6. So let's try that again, and let's try it with this other problem. Why don't you pause the video, and why don't you do it this time for this question, p of x equals -x plus 7, and plug in each of those, -3, 4, and 0, and 6, and then come back in and let's see how you did. Did you notice on this one there's a negative in front of the x? So that's that negative in front of the x. And here's where x used to be. That's the input, right? And then we're going to add 7 to it. So you got to make sure you're copying down all the symbols. Did you put a parentheses around where the x used to be? So you should have a parentheses where the x used to be. And notice the negative is in front of the x. And then just do order of operations. So a negative times a negative would make that a positive 3. So 3 plus 7 would be 10. So when you plug negative 3 into the P machine, you're getting 10 out, correct? When you plug negative 3 into the P machine, you're getting 10 out. And then let's see what happens when we plug in 4. That was an easy one. See what happens when we plug in 0. It's also an easy one. And what happens when we plug 6 in? So just to reiterate what this means, you read this P of 6. So this is read P of 6 is equal to 1. And it means that when you plug negative 6 into the P machine, you're getting 1 out. So when you plug 6 into the machine, you were getting 1 out. So input, output. Okay, on example number 2, it says find the value of x so that the function has the given value. So notice that this time we're given the output. So negative 12 is the output. So negative 12 is the output, and notice they're giving us the output this time. It's a big deal. So if we look at it from a perspective of the little function machine, right? Remember, we have the rule. So this part's the rule. So that means 8 minus 2x is the rule. We're putting something in, but they're saying negative 12 is coming out. So it's super important that you understand that they gave you the output. So negative 12 is the output. And what we're trying to find is what should go into the machine. So what value of x can go into the machine that would give us a negative 12 out. So what we're going to do is we're going to copy the rule down. And we're going to say we want the rule, right? The rule is 8 minus 2x, and we want it to have an output. We want it to equal or have out a negative 12. So we're going to say that we want the rule to have an output of negative 12. So what we're doing is we're setting up an equation. And then we're going to go back and use our wonderful algebra skills, and we're going to undo 8 by subtracting 8 to both sides. So here comes those algebra skills that we learned. And that's 0, so that's negative 2x equals negative 20. Then we're going to undo multiplying by dividing. So that tells us the input should have been 10. So the input should have been 10. So we can say that the input is 10. That would give us an output of negative 12. So we actually found the input. And that's how you write it. So once again, they gave us the output. We're trying to figure out what could you plug into the machine that would give you negative 7 as an output. That's what we're trying to figure out. What could you put into the machine that would give you negative 7 out? And we don't know. So what we're going to do is we're going to take the rule and we're going to say that 2/3 x minus 5, the rule has to give us out a negative 7. So we're going to say that that has to come out of the machine. So negative 7 was what has to come out. Then we're going to use our algebra skills, and we're going to undo subtracting 5 by adding 5. And then we could multiply everything by 3 if you want to, or it's just faster to multiply by the reciprocal. Right? Just emphasize what we're multiplying by the reciprocal. That's just faster. And 2, that gives us negative 6 divided by 2. And negative 6 divided by 2 is negative 3. So negative 3 is going to be the output. Or sorry, the input. So negative 3, right, is the input. So negative 3 is what you have to put into the machine to get negative 7 out of the machine. So if we go back, so some of you, I noticed you're doing this because you don't like to work with the fractions. And this is perfectly fine if you don't like to work with the fractions. If you instead, if you want to multiply by 3 first, instead of multiplying by the fraction, that is okay to do. You're just creating an extra step for you. But a lot of times kids feel like that's a lot easier. So that the 3's cancel out and leaves you 2x. And then negative 2 times 3 is negative 6. Then you have to divide out the 2. So you're just creating an extra step in there. But that's certainly okay too. And that we found the input needed to give us an output of negative 7. Okay, and then the other thing that you have to do in your homework, so you have 2 concepts. Now remember, we're starting to just learn these. And so the next one is to graph again. So it's the same thing. We're going to create a t-table, except for this time I'm not giving you the inputs. You actually get to choose whatever inputs you want. It didn't specify, so that means you get to choose the inputs that you're going to plug in to your table. And so you want to make some good choices. So it's always smart to maybe pick, at least one negative and pick at least one positive. And you can pick you can pick 1,000, you can pick negative 2/3, you can pick whatever you want. But we have to graph them. So I think we'd all agree we would want to pick easy numbers to work with. So when you make your t-table of your input-output t-table, you can pick whatever you want for your inputs. So be smart of your inputs. So typically you really only need 2 points to know where the line's going to be. So you really only need 2 points, but we recommend that you do 3. So why don't we plug in like negative 2, plug in maybe 0, plug in positive 2. So I picked a negative number. I always like to pick 0 because it's easy to work with. And then I picked a positive 2. So we're going to plug in negative 3 times 2 minus 1. So that's negative 6 minus 1. That's negative 7. And then we're going to do negative 3 times 0 minus 1. And then we're going to do negative 3 times 2 minus 1. I felt like we did it twice. Oh, this is supposed to be a negative 2. So negative times negative is positive. And then positive 6 minus 1 would be positive 5. So if your points don't line up, that's why it's important to do 3 points, because I just made a mistake there. And if I had only done 2 points, I would have got the wrong line. So that's why we always like to do a 3rd point. It's for more of an error analysis. So this is going to give me positive 5 when I plug in. So when I plugged in negative 2, and I plugged in 0, and I plugged in 2. And when I plugged in a negative 2, I got 5 out. When I plugged in 0, I got negative 1 out. And when I plugged in positive 2, I got negative 6 out. Negative 7 out. I don't know what I said. So it's just input, input, output, and then we're going to graph. So if we plot negative 2 as the input, so we're going to plot negative 2, 5. So negative 2, positive 5 means I have to go up. There's negative 2, 5. Now I'm going to plot 0, negative 1. So 0 is the input, and down to negative 1. And then 2, negative 7. So positive 2 is the input, and then negative 7 is the output. So if those didn't line up in a straight line, and I couldn't use a ruler to get them, I would know something was off, that maybe I did an error like I just did. So you get to choose. You could have picked 1 and -1. You could have picked 3 and -3. You could have picked -1 and +4. You can pick whichever numbers you want. The whole point of today is you get to pick the inputs. So for an example, on this t-table, since I'm going to multiply 1/4 times the input, it just makes sense that I pick numbers where 4 will go into it evenly so that I don't have to work with fractions. So when you're dividing or you're multiplying by a fraction, you want to pick numbers that, so I want to pick numbers that 4 will go into, right? Because I'm going to end up having to divide by 4. So it's being street smart. Like, technically you don't have to do that, but it's just smart to pick numbers that 4 will go into evenly. And you really only need 2 inputs, but we're asking for a third one. The more points you plot, the more you can find accuracy and the more you can look for errors. But 3 is usually good enough. So I love clicking 0 because it's easy to work with. And then remember, we said you should always pick at least one -1 and one +1. So numbers that go into 4. So -4 would be good, or even -8 or -12. Those are all numbers that 4 will go into evenly. So I'm going to pick -4 and +4. But I could have picked -4 and +8, right? Because I want numbers that go into 4 to make it easier for the math. If you start doing it and you're like, oh my gosh, it's such a pain, maybe ask yourself, maybe you didn't pick a good number. So we're going to do 1/4 times -4 and then subtract 5. So notice how I'm first just recopying, and people hate this unit because there's a lot of recopying involved. But you need to show your work and you need to make sure that what you're doing is right. So when you divide 4 into -4, doesn't that give you 1? And isn't a positive times a negative -1? And -1 minus 5 is -6. So this gives you a -6. And then when we do the same thing again, but we plug in 0. So 0 times anything is 0. Let's see why I like 0. 0 times anything is 0. And 0 minus 5 is -5. And then when I plug in +4, four goes into 4 one time. So that's 1. And then 1 minus 5 is -4. And then I'm going to plot those inputs. So I've got -4, -6. So -4 is my input, and then it's going down to -6. And I've got 0, -5. So 0 is my input, then it's going down to -5. And 4, -4, +4 is my input, and it's going down to -4. And notice how those all line up. So if yours don't line up, that means you've made a mistake. So that's what your homework is tonight. So it's a little bit of where you get to choose. Now, so what if, let me do a little erasing for a second, or let me come over here and add. Have a good day. What if the function was 1/2 x plus 5? Then what kinds of numbers would be good numbers to pick? Right? Wouldn't you want to pick numbers that 2 will go into evenly? So wouldn't it be smart to pick like -2 or -4 or -6? 0, of course, +2, +4, +6. Right? Those are smart choices because 2 goes into all of those numbers nicely. What if it was y equals x divided by 3 plus 2? We would want to pick a number that 3 goes into evenly. Right? So we'd want a number that 3 goes into evenly. So for your t-table, again, you only have to pick 3. So for your t-table, if this was the case, and we want to pick numbers, let me erase that and fix that. So you have to think about numbers that are that 3 goes into nicely. So wouldn't that be like 3 and negative 3, or 6 and negative 6, or 9 and negative 9? Aren't those all numbers that 3 goes into evenly? So if I was going to do this problem, I would probably just pick negative 3, 0, and positive 3. For this problem, I would probably just pick, negative 2, or maybe negative 4 and 0, and maybe positive 2. So it doesn't always have to be the same numbers. It could be different numbers. Okay?